So, once again, we're talking about solving trig equations, okay? And we're going to have multiple answers. So, example 1. Now, we did this in our warm-ups, but I want to show it again for Simon's sake, right? So, we were taking a look at, hold on, let me get some scissors and cut this so Simon can see this. This is for you, Simon. All right. So, I looked at graphing sine, right? We did this. So, we went from 0 to 2 pi. And I did the sine curve in green. This is my sine right here, sine of x. And the sine curve goes from 0 through pi back to 2 pi. We've done this before. We did this last month. And then I graphed the cosine as well. And so that's my cosine of x. And I graphed it in purple. And if we want to find out where sine is equal to cosine, it happens in two different spots, right? So one way to do it is by graphing. We actually showed it also on the calculator, right? We went to the intersection. We calculate our intersection points. And we can end up getting, first curve. So first curve's right about there. Second curve is right about there. Guess. But we get a decimal answer. So the decimal answer, about 0.785 blah, 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 is an answer. Now, if I want an exact answer, then that's not going to give it for you, okay? An exact answer has to come from the unit circle. So where do I see it? Well, where is sine and cosine equal? Sure enough, pi fourths, because if you look at pi fourths, you see the value square root of 2 over 2, comma square root of 2 over 2 from the unit circle. And the two values are equal, so that's where sine and cosine have to be equal. And down here, you see a negative square root of 2 over 2, comma negative square root of 2 over 2 from the unit circle, right? And that happens at 5 pi fourths. So your two values are at pi fourths and at 5 pi fourths, okay? That's where they're going to be equal, okay? That's one method to finding out where these things are equal, okay? For me, I wouldn't do that. I wouldn't do that at all. I just wanted to show that to you so that if, you're a calculator person, right, Ryan? Then you've got another way to do it, okay? However, I would do it using an identity, okay? I would come down to example 2 and say, well, wait a minute. I'm just going to divide by cosine because I know that sine divided by cosine is tangent, okay? I'm looking for an identity. So if I divide by cosine, I get tangent of x is equal to, well, cosine over cosine is 1. And then it gets pretty easy for me to do it because I know, okay, tangent equals 1. I can go to my unit circle. Yeah, we find that, remember, tangent's the pink values on that side. Well, that happens at pi fourths. Hey, I already had that answer, didn't I? And also at 5 pi fourths. Okay? So just two other methods. So what we have is really about two different ways to solve these. One is we could do it graphically and find out where they're equal. That's not the way I would do it. Or we could do it with an identity. That's the way I would do it. Okay? So I just wanted to give you more ways to do this, which I know, Ryan, you appreciate, don't you? Yeah. Okay? So not bad? I like the identity. Thumbs up?
Yeah.
Okay. Do you guys like the identity or do you like the graphing? You like the graphing? Nothing wrong with the graphing. That's fine too. Yeah. Well,
last night, is it going to be totally different?
It can be challenging. Let's take a look at example 2, okay? All right. Now, example 3. So in example 3, before we do example 3, let's go ahead and divide by 2, and we get a sine of 3 theta equals 1/2, right? And again, on our warm-up, I did this one on purpose, didn't I? So let's go back and take a look at our warm-up. So it can be done graphically. It can. But I'm going to show you another way, a way that I think is easier, okay? It can be done graphically. You can go and graph, remember the sine of 3 theta, we're going to have 1, 2, 3 curves, right? We're going to have 3 curves within 2 pi. That's what the 3 theta means, because I've got to fit 3 curves in 2 pi, which means the period of this thing has to be 2 pi thirds. And sure enough, it is, right? And then we can say, okay, value of 1/2, where is equal 1/2? Here, 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 here. Now again, you could do this on your calculator. You really can. You're not going to get the answers I like, but you can do it on a calculator. So if I go, okay, well, y equals, clear that, go back up and go a sine of 3 theta. Okay, so I'm going to go sine of 3 theta, or x, and do a 1/2 or 0.5. Okay, so I'm going to graph the sine curve, and you're going to see that roll along, and it should look like this curve here, right? And then 1/2 should be a line straight across. That makes sense. I should get a horizontal line, and we'll see where they intersect. So I go hit graph. Okay, there's my 3 sine curves in 2 pi, right? And here's 1/2. And you can see where the 6 intersection points are, right? So if you wanted to take the time of finding all the intersection points, you can go, okay, calculate. And let's do 1, because I do not want to do all 6 intersect, right? Let's find the first one. Intersect, enter, second curve, enter, guess. So it's about a 0.174, blah, 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 right? Okay, that's one of the answers. And then, of course, you'd have to keep going to get all 6, okay? I think there's an easier way, honestly. I think there's an easier way, okay? So let me show you how I would do it, okay? I would do it this way. So I'm going to look for where sine is equal to 1/2. So on the unit circle, sine is equal to 1/2 at pi 6, right? Okay, so I look at the unit circle, where is sine equal to pi 6? So theta, it's not theta, it's 3 theta. So really what I have is 3 theta is equal to pi 6, right? And where else does sine equal 1/2? It equals at 5 pi 6. Okay, do you see it? Sine is the y value, 1/2. So I'm going to have also a 3 theta equals a 5 pi 6. Okay?
Can you scoot it up?
Sure, yeah. Sorry, you guys. How'd I lose that? No one. Okay. So I looked at the inner circle. Where does sine equal 1/2? At pi 6. But that's 3 theta. That's not theta. It's 3 theta this time. And where does it also equal 1/2? At 5 pi 6. But that's not theta. It's 3 theta. Okay, so let's solve for theta. Let's just divide by 3. Divide by 3, right? So one answer is pi 18ths, which, believe it or not, the decimal equivalent of this 0.17 blah, blah, blah is pi 18ths. It has to be, right? So then, divide by 3, and I get theta equals 5 pi 18ths here. So let me look at my graph. You guys have that? So on my graph, this is pi 18ths. And on my graph, this is my 5 pi 18ths, all right? Does that make sense?
Can you move it up just a tiny bit?
Yeah. That?
Yeah, I just need to get.
So graphically, let's see what we have, okay? So I got my pi 6 divided by 3, and I got pi 18ths. So this intersection right here is pi 18ths. It has to be, right? It also, on the calculus, is the same equivalent as decimals 0.174, blah, blah, blah. Everybody good on that? Does that make sense? And the other graph, the other point of intersection right here is a 5 pi 18ths, because I divided by 3, and I got 5 pi 18ths. Okay, now, if I want all 6 of them, then I'm just going to do this, okay? So I'm going to say, okay, well, I'm going to take theta 2, because there's 6 answers, right? So I got theta 1, theta 2. How about theta 3? It's going to be pi 18ths plus, right? So the next one is right there. Right there. The next one's right there. How do I get from here to here? I'm going to add 2 pi. So it's it's plus 2 pi thirds. Okay. 2 pi thirds, because what is the period of this curve? 2 pi thirds, isn't it? Right? So you're just going to be moving 2 pi thirds over. And so I can do the same thing on the other side and say, okay, I can say that theta 4, 5, and 6, right, is going to be my 5 pi 18ths plus my 2 pi thirds, bad looking pi thirds, k, and k would be, you know, the value of 1, 2, and 3. That gets us all of our answers. Stay awake. Stay awake. Okay? Does that make sense on why I ended up getting all those answers? If you look at graphically, I think it really makes sense if you look at it. Look at the graph. And I think you also can see that the period really is 2 pi thirds. So you jump in 2 pi thirds, you're going to jump another 2 pi thirds. You're going to start here, jump 2 pi thirds, and jump another 2 pi thirds. Okay? Capiche? Thumbs up? Okay, not bad? Okay, now, let's look at example 4. Okay, example 4. So before I do a whole lot, let's first solve it as much as we can. So divide by the square root of 3, divide by first plus 1, square root of 3, tangent of, let's make it theta over 2 equals 1, right? I just added the 1, brought over the 1. Divide by the square root of 3, so tangent of theta over 2 equals 1 over the square root of 3, right? I just divide by the square root of 3, divide by the square root of 3. Now I'm going to rationalize this, make it a better answer so I can find out the unit circle. No, that's okay. Colby, I make mistakes all the time, so question everything I do. But I think I'm right this time, okay? So then I've got a tangent of theta over 2 equals square root of 3 over 3. Now I wanted to rationalize it because that's a unit circle answer. But before I do anything, let's think about what the graph looks like, because we may have multiple answers, right? So if I go back to what a tangent curve looks like, all right? Yes, yeah. So, and I'm going to do it in pencil because I'm going to move some things around. So the tangent curve, a normal tangent curve looks like this. Negative pi halves, asymptote, right? A normal tangent curve looks like this, okay? But I want to look at only half a tangent curve in this space, okay? So what's going to happen? This curve is going to be really much wider, So what we're really going to get is, you ready? We're going to get this to be not pi halves, but pi, not pi halves, but pi. And that would give me a new period of from pi, negative pi to pi, okay? So now, where is this thing going to equal square root of 3 over 2? So square root of 3 over 2 might be around here. Square root of 3 over 3 might be somewhere around here. Height of 1. So we should have one answer. Only one answer. Visually, we should see only one answer. So how do I get that one answer? Well, let's just go to the unit circle, all right? So go to the unit circle. Square root of 3 over 3 for tangent puts me at pi thirds. You guys agree? See the pi thirds? So then I've got...
Pi 6? Isn't it pi 6?
Yeah, pi 6. So I've got theta over 2 equals pi 6. I was ahead of myself. I'm going to get a pi thirds in a second. Okay. So now I've got to solve for theta. Let's multiply both sides by 2. Multiply by 2, times by 2, times by 2. So my answer, theta, is equal to 2/6 or 1/3 pi thirds. So can we do this on the calculator? Maybe. Let's see if we can. Let's check it out. So on y equals clear. So let's do my original. I probably will do it right here, okay? I'll graph this part right here, so it's equal to 1, okay? So I'll go square root of 3. Oh, shoot. Delete. Clear. Let's do the square root of 3. Tangent x divided by 2, okay? And we'll put in 1 and graph them. Let's see what it looks like. Oh, let me change my window too. My window, I want to go from negative pi to pi, right? And we're going to go a little higher, maybe negative 3 to 3. Let's see what it looks like, okay? Graph. And of course, it's not going to show the asymptotes because those are... Boom, there's my one intersection, okay? So I kind of knew one point. Okay, and if I want to use a calculator, I can go to calculate, intersect, right? Yeah. Sorry, you guys. Intersect, enter, guess, there it is. So I got about a 1.047 blah, 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 which is pi thirds. Yeah, which is pi thirds, right? Okay, there you go. So one of the ways you can do, okay, and before I finish recording, and you know, this is kind of the way I did it sometimes too, and you're smart. So you can do it by the calculator. And then you can play around and figure out which one it is. So you can write this number down and say, well, which value is that, right, Ryan? Is that what you do? Is that how you might do it? So you write this value down, you figure, okay, which one of those is equivalent? So I'd go through. You see what I would do?
Oh, I just start going pi divided by 2, pi divided by
Yeah, until you get that. Exactly. Until you get that and you go, hey, I got the exact answer.
Like pi divided by 12.
Aren't you glad I told you that little trick? Because sometimes when I was in college and I couldn't figure it out, I would find other ways to figure things out, right? I mean, there's more than one way to do it, right? You like that? All right. That was my survival mode in college math. I'd say, okay, there's got to be another way to do it.